In this video, I'll be quickly explaining value semantics with a simple example. So consider this function, which takes a reference to a vector of strings and a standard string, and it does vector.pushback_s. Question for you is, how many times is the string copied from the moment it's created? Now, the problem here is that the string is actually copied twice. Copied once to pass it by value here. So when we do the call to append, it's copied. And when we push back, we copy again. As you can see, this takes a const reference to a string, and it's going to have to copy the string to place it inside here. And we can tell that the string is at least copied one time because I can run here. Sorry, this is void. I thought I marked this like main. So you can see that S is still intact. Now, what C++ allows us to do is to add an ampersand after our types. Similarly to a reference, this is going to be called an R-value reference. And what it means is it only accepts a temporary object. Now, look at that. Here we get an error, and it says cannot be bound to, it says R value cannot be bound to an L value. So this is an L value. We've given this string a name. It's a variable inside our scope, and I'm trying to call this using a temporary R value, and it's just not correct. So what we can do, keep in mind, this is strictly to avoid copying what I'm doing, is we can move the string. And now what that tells the compiler is that move here, what it does, it takes an L value, a reference, it turns it into an R value. So what that does here is we have marked the function here to take a temporary, and now we've forced S to behave like a temporary. Now let's run this again and see what happens. That's weird, right? We've moved S into here, but it didn't get updated. What exactly happened? Well, right now, the function is behaving essentially exactly like this. So with this example, we're not copying S, we're taking it by reference, but we're still copying it here. So if I run, we can see that S is indeed not changed. So there's one part missing to this story, which is to move S into the vector. So S is an L value. We move it so that it behaves like an R value. We take the R value, but because it's a parameter and it has a name, it's now an L value, and we need to move it again. And now if we hover pushback, we'll see that this is the overload of pushback that takes an R value. Can I see it? So as you can see, it takes an R value and it calls move on it. So essentially, every time you have an R value, typically you want to move from it. So what the R value tells you as a programmer is that you're allowed to move from it. Where, imagine if I did this. If I take by reference, this is arguably just wrong because I mean, it's fine, right? We're taking by reference and we're stealing it. It's just that at that point, it's kind of alarming to be taking by reference if that's what we're going to be doing. Typically, if you're taking by reference and you're going to move from, there can be cases where that's fine. But since here the only thing we're doing is taking the thing and moving it, it's probably better to take by R value. And now there's another advantage of doing so. Imagine if we had our, I'm going to comment, no, I'm going to do this. So imagine if we take by reference, but now we want to do this, append vec 1, 2, 3. Oops, sorry, I put that into strings as well. So now we're getting an error. Reference of type standard string cannot be initialized with a const char. Now you might be thinking, no, but you need to put a string here. But indeed, that is not the problem. So now the error we're getting is initial value of reference to non-const must be an L value. So this is the reference to non-const, and this is the thing that it's complaining that is not an L value. Indeed, it's not an L value because it doesn't have a name. We're just creating an object here. This would be the same if you had something like this. We're going to get the exact same error here. Initial value of reference to non-const must be an L value. So once again, the result from this doesn't have a name, so it can't be bound to a reference. But if we do this and we take by R value, now it's fine. So R value means temporary. The only time where it's not a temporary is if you do something like this to trick the compiler into taking an L value and treating it like an R value. It's not really a trick, and this is called an X value because S has a name, and all we're doing is asking the compiler to make it so it behaves like an R value. So this whole thing about R value, L value, taking by R value, taking by reference, taking by value, there's different things that you can do. It's all about avoiding copy. If you don't care about avoiding copy and you write code like this, then that's fine. This code is correct. It's just slower. Now, if you don't care that it's slower and you're just really worried that you might mess up by trying to write R values and maybe moving incorrectly, then you don't have to, but your code is going to be slower. There are times when you do have to move. So I'm going to give an example here. So here, as you can see, this code is correct. So we can either make a non-copyable and then move it into the vector, or we can make a non-copyable right there and it's going to bind to the R value ref. And we need to move. So now, as I was saying before, if you have strings and you take by value, there's no problem. But if you have a non-copyable object, you might expect that this wouldn't compile, but this is actually correct. There's no copy involved right now. And we know there's no copy involved because the copy constructor is deleted. So you can't take by value even if the type is not copyable. So that's something that maybe you didn't know, but it's very rarely useful, I want to say. But what you cannot do is this. So now, as you can see, it's taking by const reference. It's going to try to copy, and it's not going to work. So it says attempting to reference deleted function copy constructor. And if we look at the call context, it says it's this line. And then if I go into vector, somewhere we might be able to see, but this code is pretty unreadable, right? So anyway, it's trying to make a copy. So you are going to inevitably have sometimes to write standard move. There is no way around it. What you can sometimes avoid is taking by R value, because if your type is not copyable, then you don't need to protect the user against copies. So remember, if you have a function, for example, that takes a string by value, that just means that the user that calls the function might make a copy. So if you're trying to protect someone from making a copy because you need a value, it's better to mark it as an R value. But in the event where the type is not copyable anyway, this doesn't change anything. I'm going to make a final point about value semantics with a kind of weird example. Consider these two functions, void f int and void f int ref. Now I'm going to make an int. Now, if I call f of a, which do you think is going to be called? I hope you have your answer. I hope that if you think that it's one of the two, it's going to be the second one, but sadly you'd be wrong. This is a shortcoming, I think, of the compiler, but it thinks that it can't find the right function to call. In my mind, obviously it should call the reference. If you pass a value, it's fine. It calls the value one. If you call, if we did standard move A, it also calls the value one. But if we just call it with an L value, sadly it can't. Now there's one way to solve this. Value semantics to the rescue. If we mark this as an R value, now we're fine. So if we call it with A, it calls the L value. If we call it with 1, it calls the R value. And if we move, and if we move A, it calls the R value. It's that simple. So yeah, in my mind, this values versus references thing, it's all about copying and ownership. So in further videos, I'll be talking about copy construction and default member functions, or special member functions rather, that you should default or use a rule of 0. There's going to be a video about the rule of 0. I'm going to be talking about templates and the pitfall of R value references versus universal references. And I'm going to have a value about constructing types, which is going to come back to this references versus values. And when you add a reference to a type, what happens? You no longer can copy construct. So I did want to mention one more video, but I forgot about it. So anyway, you can check out the playlist in the description. You can also check out the presentation that is available. There's going to be the link where I'm going through all of the C++ concepts I've identified and adding some along the way. So this is the very first video. So stay tuned for related videos very soon, and unrelated videos eventually about pretty much all of the concepts about modern C++ that I think everyone should know. Well, maybe not everyone, but you know, C++ developers.